Uh, Optical fiber and introduction of the optical fiber we discussed. Okay, today we'll discuss about the different types of optical fiber and so working principle of the optical fiber we will discuss. Okay, yeah, so my screen is visible. Yesterday we discussed about the here optical fiber introduction and so different parts so parts are there in optical fiber. We will discuss about those parts also. Okay, again I will explain briefly regarding about these parts. See here. So this is here, so core will be there inside, around that core cladding will be there. So what is the use of core means, through the core only that light will be transmitted. So here cladding, the core and cladding refractive index will be different. Okay, so that means here core refractive index is high, cladding refractive index will be low. So when light is transmitted from denser medium to refractive index is high means, so that medium we will call it as denser medium. So here refractive index is low. So here light is moving from denser medium to rarer medium. What happened? So total internal reflection will be takes place. If angle, instant angle is greater than the critical angle, at that situation total internal reflection will be takes place based on this principle. So here it will work. Okay, so inside it will be there, that is core, around that core cladding will be there. So okay, and around, that means on the cladding there is a some coating will be there, that is the silicon coating. It will protect the transmission, that means quality of transmission. So it will improve the quality of transmission, that means it will protect from any light losses. Okay, transmission losses. Okay, that is about the use of the silicon coating. So on the silicon coating there is a buffer jacket will be there. So in this buffer jacket protect from the moisture and some, what is that, mm, so rubbing, any, if any rubbing will be there, or any so thing will be there, any losses will be there because of the rubbing, some material losses will be there. So that is, we will call it as aberration. Because of that aberration, okay, may chance to lose the material, it protect the so material silicon coating, as well as okay, moisture, it protect from the moisture also. That is the buffer jacket used. And strength membranes means it provide the tensile strength to the, so this optical fiber. And again, so one more is there, that is the uh, polyethylene outer jacket. So it protect the so tensile strength as well as toughness and so bending strength also. Okay, so this is about the different parts of the optical fiber. Okay, now coming to the principle of optical fiber. So principle of optical fiber works on the principle of total internal reflection. Okay, already we discussed about that. So once again I will explain you what is the total internal reflection. Once light ray enters into the core, it propagates by means of multiple total internal reflections at core cladding interface. So because here core is the higher refractive index, cladding is the lower refractive index. Because so when light is traveling from the rarer medium to denser medium, here total internal reflection will be takes place. That's why, so because of that total internal reflection, what happen, light will be propagate inside the optical fiber. Inside the optical fiber there are certain conditions will be there total for total internal reflection. Okay, so what are those conditions? If total internal reflection will follow some certain conditions, then only, so if the conditions will follow, then only total internal reflection will be takes place. Otherwise total internal reflection does not takes place. What are those conditions? So first condition is, so already we discussed, so refractive index of core material N1 must be slightly higher than the cladding material. That means refractive index of core is greater than the refractive index of cladding. That means here refractive index of core is N1, refractive index of cladding is N2. So therefore N1 is greater than N2. This is the first condition. First condition for to getting the total internal reflection. Now second condition. What is the second condition means? So that angle. Okay. So what is that means? At the core cladding interface. Core cladding interface means see here. So this is the core here. So this is the core. This is the cladding. So interface. Interface means in between the core and cladding. In between the core and cladding. Okay. So that core cladding interface, so the angle of incidence theta I must be greater than the critical angle theta c. Okay, so here once light is enter inside the core, so and it touches to the cladding, it touches to the cladding, where it will touches, so at that place, so that is the core cladding interface. So that angle should be greater than the critical angle, where it will touches to the core cladding interface. So at that place, that angle should be greater than the critical angle. So then only total internal reflection will be takes place. Okay, otherwise there is no total internal reflection. Already we know that that is the condition for total internal reflection. That means here, so that incident angle should be greater than the critical angle. Incident angle. So incident angle is nothing but at core cladding interface incident angle. Okay, is greater than the critical angle. Okay, so this is the two conditions for so total internal reflection. First one is n1 greater than n2. N1 means so refractive index of core, and n2 is refractive index of cladding. Refractive index of core is greater than the refractive index of cladding. That is the first condition. Second condition is incident angle should be greater than the critical angle. Okay, incident angle, where we have to take that incident angle, core cladding interface. So core cladding interface, so incident angle of the core cladding interfaces should be greater than the critical angle. Okay, so how to calculate the critical angle? There is a one formula will be there. I will explain you how to calculate the critical angle also. So first of all, see here. So these are the diagrams for so how it will work. So total internal reflection will be takes place. See here. So this is the instant ray. This is the instant ray. That ray is in denser medium. Okay. So this is the refracted ray, and that is in rarer medium. Rarer medium. So this angle theta I initially less than the critical angle. Initially theta I is less than the critical angle. What happened? So that instant angle, so refracted ray is moving in another medium. Okay, rarer medium. Now see here. So if theta I is equal to the critical angle, okay, at a particular angle, so that instant angle is equal to the critical angle. What we are doing now, we are increasing the instant angle. Initially, yeah, I will explain you through diagram. See here. So initially that instant angle will be like this. Similarly, so now we are again increasing that angle. So again we are increasing that angle. So what happened? It will bends like this. It will bends like this. And if you increase, so again this angle, sorry, if you increase angle like this at a particular angle, what happened? So that light will bends like this. So that angle we will call it as critical angle. At which angle? At each angle, so that what is that that reflected angle will be there na? That will become 90 degrees. That will become 90 degrees. That angle we will call it as critical angle. At which instant angle? At which instant angle that reflected angle will become 90 degrees. So that angle we will call it as, so that instant angle is called as critical angle. At which instant angle? So this will become 90 degrees. So that angle we will call it as critical angle. If instant angle is greater than the, so this critical angle, then only total internal reflection will be takes place. Okay, see here. So theta is greater than theta c. Here total internal reflection will be takes place. That means all light, whatever incident on here, that total light will be reflected into the same medium. Reflected into the same medium. It will not passes to the, that means there is no transmission or refraction. Total it will be reflected back. Okay, so if it is coming like this, means that we will call it as transmission or refraction. transmission or refraction, but there is no refraction here, only total light is reflecting back. Okay, so this is called as total internal reflection. Now, so we will find out the what is the critical angle. What is the critical angle we have to calculate here? So we know that according to the law of refraction, so when light is refracting from this medium to another medium, what happened? There is some law will be there. That law is Snell's law. Okay, n1 sin I is equal to n2 sin r. Okay, here instant angle is equal to theta I, n1 sin theta 1 equal to n2 sin r, refracted angle. So here refracted angle equal to r. Okay, that's why. So I am writing condition for this one. Okay, so for this condition, so for this transmission, for this diagram, I am writing the here condition. After that we will convert into so we will apply to the that critical angle, that so according to law of refraction. So if ray is refracting means that should follow this law, n1 sin theta I is equal to n2 sin r. Okay, what is n1? N1 is the refractive index of the one medium, so first medium. N2 is the refractive index of the second medium. Okay, now coming to the, so if this instant angle is equal to the critical angle, if instant angle is equal to the theta I is equal to the critical angle, now what happened? So if theta is equal to theta c means r will become 90 degrees now. See here, so according to this diagram, so theta I is equal to the theta c. Now r, so refracting angle is equal to the 90 degrees. Refracting angle equal to 90 degrees. Okay, yeah, now we substitute here theta I is equal to theta c. Instead of theta I we are substituting theta c, so that therefore so r will become 90 degrees. So r, instead of r we are substituting 90 degrees. Okay, sin 90 value is 1. Therefore sin theta c is equal to n2 by n1. Sin theta c equal to n2 by n1. Theta c is equal to sin inverse of n2 by n1. So that this is equal to the critical angle. So sin theta c is equal to n2 by n1. N2 is the refractive index of the rarer medium. N1 is the refractive index of the denser medium. Okay, sin theta c is equal to n2 by n1. This is the critical angle. Now coming to the acceptance angle. So this critical angle is different, acceptance angle is different. How it will be different, I will explain you. Okay, see here, so this is the I am drawing here optical fiber diagram. Okay, this is the core. Okay, core, around that core there is a cladding will be there. Here cladding will be there. Okay, see here. Okay, 1 minute. So this is the core. So when light is, so what happens? Suppose light is instant. So this is the, I will center of the core. This is the center of the core. I am drawing here axis of the core. This is the axis of the core. Okay. When light is enter into the core. When light is enter into the core. Okay. So and it will be instant on the core cladding interface. This is the core cladding interface. So I am drawing one normal here. I am drawing one normal. So this angle should make here, so how much it will be? So greater than critical angle. So I am drawing one normal line here. Okay, now so this angle should be greater than the critical angle. This instant angle should be greater than the critical angle. So here also this is air, so this is the core. Here what happened? Medium is changes. Medium is changes means, so if light is traveling from one medium to another medium, what happened? It will bend now. It will refract. It will refract. That's why here angle is different. Here angle is different. Here angle is different. So angles are different. That means this. So in air this angle is different. Here it will bends like. So that's why here angle is different. So angle will be changes. Angle will be changes. Okay. So that's why. So in which angle we have to apply? We have to apply in air. Okay, this is the angle. Critical angle is inside the core cladding interface. Okay, so inside the core cladding interface should be greater than the theta c. Okay, for that what we have to do, we have to apply the sufficient angle. We have to apply the sufficient angle. That angle we will call it as acceptance angle. See here, the maximum angle of incidence at which the end phase of an optical fiber for which light ray can be propagate along the core cladding interface is known as maximum acceptance angle. Suppose in which angle one light ray is enter here. So what happened if light ray is traveling throughout the one end to another end? So then only, so what happened, we will call it as this angle, we will acceptance angle. Okay, otherwise we are applying some light ray here, so like this angle. So what happened, so this light ray bends somewhere like this. So suppose, yeah, so this is the air interface, I am applying one ray. Okay, this is the core here, so core, so whenever enter into the core, it will be reflect like this, it will be refract like this. Okay, it will be refract some angle, it will not come exactly, and that refracting angle should be make at the interface greater than theta c. Okay, then only total internal reflection will be takes place. So what for that, what we should make, there is a, we have to apply appropriate angle here, appropriate angle. So what is the maximum angle to apply to propagate the ray, to propagate the ray into the, so inside the core? Okay, that angle we will call it as acceptance angle. Okay, see here, I will explain you here. So this is the instant light, so light is instant in here. So because, so let us take that angle is I, that angle makes here with the so this is, I am drawing one normal line, so that through that normal line, this is making angle theta, this is making an angle theta, and now this is refracted, this is refracted, that refracted angle is theta r, refracted angle is theta r, and here, so this is making one angle here, so that should be greater than, that is the instant angle theta I, that should be greater than the critical angle, then only total internal reflection will be takes place. Okay, so whatever required angle here, what is the maximum angle is required to propagate the total internal reflection? Okay, that maximum angle we will call it as what so this angle we will call it as acceptance angle, acceptance angle. Okay, now we have to find out the what is the acceptance angle, what is the acceptance angle we have to find out here. Okay, that acceptance angle means, so what is the angle of incident, what is the angle of incident light ray? Okay, so that acceptance angle we have to calculate. For that, so first of all we have to apply the Snell's law. For here we are applying the Snell's law here, so that is the air interface and this is the core interface. Okay, so now what is the refractive index of the core? N1. So what is the refractive index of air? N0. We are taking here, yeah, we are taking, we are applying the Snell's law for air and core medium, air and core medium. For that I am explaining you here. Yeah, so here this is the optical fiber, optical fiber, this is the center of the optical fiber. So and I am drawing one normal here. Okay, now so I am applying the, so this is the axis of the optical fiber. Okay, now one ray is applying here, one ray is applying here, so angle between the normal and, so this ray, that is called as theta, so theta I, that is the theta I, and this is N0, this is N0, refractive index of the air, and this angle between the instant and normal, instant and normal, that is theta I. Now this instant angle is refracted inside the, so that is instant like this, now it will be refracted like this, refracted like this. So this refracted angle equal to theta r, refracted angle equal to theta r. Okay, now this is the theta r here, this is refractive angle, we will call it as theta r, and the refractive index is here N1. Okay, now we will apply the Snell's law here. If you apply the Snell's law, what happened? N naught into theta I, sin theta I equal to N1 into sin theta R. Okay. Now, so here if you take, so there is a, if you draw normal here, if you draw normal here, so there is a one angle, so here theta R, and this is the, here angle making is theta. Okay, so this here it will makes an angle theta, so theta R plus theta, so these two angles, sum of the three angles in triangle, this is the one triangle na, so this is one triangle here. Okay, so this angle is theta R, this angle is theta, this angle is theta, this angle is 90, because this is normal line. Okay, so total angles, so in triangle equal to 180, that means theta R plus theta plus 9, so 90 equal to 180 na. So now theta R plus theta is equal to 180 minus 90. Okay, that equal to 90. So that means, so this angle theta R plus theta, these two equal to 90 degrees, theta R plus theta equal to 90 degrees. Therefore, so theta R, this value theta R is equal to 90 minus theta, 90 minus theta. So if you substitute here instead of theta R this value, so 90 minus theta. Okay, now we will get N naught into sin theta I equal to N1 into cos theta. So 90 sin 90 minus theta equal to, we can write cos theta na. Okay, therefore above formula will become, so 90, so N naught into sin theta I is equal to N1 into cos theta, N1 into cos theta. Now therefore sin theta I is equal to N1 by N naught into cos theta. Okay, understood here? This is the, so theta I, and this is the theta R. So this theta R makes an angle theta here. Okay, now this is a triangle. So in the triangle, theta R plus theta is equal to 90 degrees. So therefore theta R is equal to 90 minus theta. I am substituting theta R value here. So therefore, so here sin 90 minus theta. Sin 90 minus theta means, so it will become cos theta. So therefore this will become, so sin theta I equal to N1 by, so N naught into cos theta. Let us take, this is equation number 2. Okay, now coming to the, so when theta is critical angle, theta C. Okay, see here. So this is angle, this is the theta na. So this theta will become theta C. So then only total internal reflection will be takes place. Okay, that's why I am taking here. So when theta equal to theta C, critical angle. Now what happened here? So theta I, this is the theta I, instant angle. Instant angle will become, so acceptance angle na. So if your total internal reflection will be takes place inside the core, total internal reflection will be takes place. That means, so that instant angle is acceptance angle. Okay, so here, so total internal does not takes place means that instant angle is not a acceptance angle. Instant angle is not a acceptance angle. So inside, so total internal reflection will be takes place means, so that instant angle is called as acceptance angle. Now, so according to that, inside, so total internal reflection is takes place. That's why that instant angle we will call it as acceptance angle. Acceptance angle generally we will mention here theta m. Okay, so if theta in place of theta we are substituting theta c. That's why, so what we are doing here, instead of theta I, we are substituting here theta m. Okay, now sin theta m is equal to N1 by N naught into cos theta c. Above formula, same formula. In that formula, sin theta is equal to N1 by N naught into cos theta. In that formula, we are substituting, instead of theta, we are substituting theta c. Therefore, theta I will become theta m. Okay, so theta I will become theta m here. So sin theta m equal to N1 by N naught into cos theta c. Okay, let us take, this is equation number 3. Okay, already we know that, so no need this total part here. Okay, so this part is not required for you. Again, we are proving here, so that is not required. This part is not required for us. So directly we know that formula, sin theta c formula. We proved previously, sin theta c is equal to N2 by N1 into sin 90. Okay, that means, so directly we can write sin theta c is equal to, so N2 by N1. So this is the formula for critical angle. Sin theta c is equal to N2 by N1. We will substitute the sin theta. So we have to convert the sin theta c into cos theta c. So there is a relation between sin theta c and cos theta c. So cos theta is equal to under root of 1 minus sin square theta c. Okay, so if you substitute the sine theta c value here, okay, so sine theta c value, therefore cos theta c is equal to under root of 1 minus n2 by n1 whole square. If you simplify it, cos theta is equal to under root of n1 square minus n2 square by n1. Okay, now so this sine theta c value, substitute in equation number 3. Substitute the cos theta c value in equation number 3. Therefore, sine theta m is equal to n1 by n0. See here, n1 by n0 into cos theta c. Cos theta c value is under root of n1 square minus n2 square by n1. Here n1 gets cancelled, and we are taking medium. So medium is air medium. Here we are taking here. So this medium is air medium. Air medium means, so this medium is air medium. So air medium means, so for air, what is the refractive index? Refractive index value is 1. Okay, that's why. So we are taking, instead of n0, we are taking 1 for air. So the refractive index is 1. That's why instead of n0 we are taking 1, and n1 gets cancelled. Sin theta m equal to under root of n1 square minus n2 square. So theta maximum is equal to sine inverse of under root of n1 square minus n2 square. So this angle is called as, the maximum angle is called as acceptance angle or acceptance cone of angle. Okay, this angle we will call it as acceptance angle or acceptance cone of angle. Okay, so this is the acceptance angle. Now coming to the acceptance cone. Acceptance cone. So this acceptance angle theta m, we said that. So that theta m or acceptance cone angle also of. So this is the total cone here. So this is the total cone. So this angle is, so theta m. That means that is the acceptance cone of angle. Okay. Now how to find out the acceptance cone? How to find out the acceptance cone means, so one side, if you draw a line, so one side means that is the acceptance angle. We said that. So this angle should be greater than, that angle should be greater than the, so theta m. Then we will call it as, so that that is the maximum angle. That is the maximum angle, and we will also call it as acceptance angle. Acceptance angle. Okay. See, so that means rotating the acceptance angle about the fiber axis. Describe the acceptance cone of the fiber. So here we are taking, this is the acceptance angle. So this angle we can rotate. Rotating is nothing but we will draw that line in all directions. Suppose, so only, so previous case we are taking only one direction. Suppose I may chance to light enter into this direction also. So this direction also we will find out the theta m. So like this direction also, so like it will, light will be instant. That means all 3-dimension direction, all 3-dimension direction will take, the theta m value means, so this will become like a cone. That means, so just we will rotate the this line into 3-dimension, three dimension, it will become a cone. This cone we will call it as acceptance cone. Okay. If light ray is instant inside the cone only, if light ray is instant inside the cone only, what happen? So that light will be propagate. So suppose if light ray is, so instant from here, that light is not propagate inside the fiber. Okay, that means, so light ray is, so if light ray is instant within the cone, if light ray is instant within the cone, then only propagation will be takes place. Light is transmitted from one medium to another, one side to another side in an optical fiber, one side to another end of the optical fiber. Okay, if I suppose if incident light is, so greater than this theta m, incident light is greater than this theta m, what happens? That light is not propagate, light not propagate. If light is entered inside the cone, if light is entered inside the cone, then only that light will be propagate, otherwise light does not propagate. Okay, so this is about the acceptance cone. Okay, so that means if light is enter inside the cone, then only total internal reflection will be takes place inside the optical fiber. Okay, that, so that cone we will call it as acceptance cone. Okay, acceptance cone. So this angle will be there na theta m. That angle we will call it as acceptance angle or acceptance of cone angle. So this total angle, see here. So this total angle is cone angle, acceptance cone angle. But half of this angle is half angle of acceptance cone or acceptance angle. Okay, now coming to the numerical aperture. Numerical aperture. So here this is the theta max acceptance angle. Na? So numerical aperture equal to sine of the acceptance angle. Numerical formula for numerical aperture equal to sine of the acceptance angle. Okay, that is the formula for numerical aperture. So what is the definition of numerical aperture? So what is the definition of numerical aperture? Means just simply the light gathering capacity of the optical fiber is known as numerical aperture. Numerical aperture is nothing but light gathering capacity of the optical fiber, that is called as numerical aperture. So formula for numerical aperture equal to sine of theta maximum. Theta maximum is called as acceptance angle, sine of acceptance angle. So sine of theta max, already we proved this. Sine of theta max equal to, so there is a formula will be there, under root of n1 square minus n2 square by n0. Therefore numerical aperture equal to, so here n0 equal to, for air n0 equal to 1, n0 equal to 1. Therefore numerical aperture will become under root of n1 square minus n2 square. Okay, so we will further simplify this formula. So there is a, so we can write a square minus b square, we can write into a plus b into a minus b, like that n1 plus n2 into n1 minus n2 we can write. Okay, so but there is a difference n1 minus n2 by n1. Okay, that is a difference between the refractive index. Okay, variation of refractive index, so that is the delta. So variation of refractive index n1 minus n2 by n1. Okay, so that is the delta. So therefore we are multiplying with n1 and dividing with n1 here, n1 minus n2 by n1. This is the delta, this value we can write delta. So again we are multiplying with n1, so that's why n1 into delta into n1 plus n2. So this is the numerical aperture. So approximately some cases here n1 is approximately equal to the n2. N1 is approximately equal to the, so n2. So while using minus term, we don't take n1 approximately equal to n2. So while using only plus term, so approximately, if you adding is, there is no problem. If you will take this in this case, so n1 equal to n2 means what happen? It will become 0. So that means so there is no numerical aperture value. That's why, so only while adding we will take approximate value. So n1 approximately equal to the n2, because so that both material is prepared with the same silica only. So core and cladding are preparing with the silica only. So their refractive index is just varies. I only suppose its refractive index of core will be 1.5 means, so cladding refractive index will be 1.7, just 0.2. The difference between the refractive index is just so 0.2. Okay, that's why we are taking approximately equal here. Okay, therefore numerical aperture formula will become, so n1 plus n2 means we can take 2n1 2n1, already n1 will be there, so that's why n1 square into 2 delta, numerical aperture value equal to n1 into 2 delta. Okay, so this is the another formula. So this is the one formula. So numerical aperture equal to under root of n1 square minus n2 square. Another formula equal to numerical aperture n1 into under root of 2 delta. So delta means only they give the so this difference. So they didn't give n2 value sometimes. So they didn't give n2 value. Just they give the difference between the refractive index of the core and cladding. At that situation, we will take delta. Okay. This is the numerical aperture value. So what is the formula for numerical, what is the definition of numerical aperture? Means just light gathering capacity of the optical fiber is called as numerical aperture. Okay, now so types of optical fibers, so there are, so based on the here so refractive index. Based on the refractive index, so there are two types of optical fiber is there. So one is the step index optical fiber, another one is the graded index optical fiber. Okay, so based on the refractive index, so there are two types of optical fibers will be there. One is the step index optical fiber, another one is the graded index optical fiber. Here graded, not grade X. So graded index optical fiber. Okay, next one is the based on the mode of propagation. Based on the mode of propagation, there are two types. Again, two types of optical fibers are there. Those are the single mode optical fiber and multi-mode optical fibers. Multi-mode optical fiber. Okay, so based on the refractive index and based on the mode of propagation. Okay, based on the refractive index, there are two types are there: step index and graded index. Okay, based on the mode of propagation means, so there is a single mode of propagation and multi-mode propagation. Okay, now so based on the type of material also, which type of material we are using. So sometimes we will use core as a plastic, sometimes we will use core as a glass material. So based on the type of material also, there are some classification will be there, that is, those are not required for us. Okay, now classification based on the mode of propagation. So here, so based on the mode of propagation, there are single mode optical fiber and multi-mode optical fiber. So there is only one mode of propagation will be there. So total material, so inside only one mode of propagation will be there, means we will call it as single mode propagation. So there are more than modes, one mode, and that means, so that light is propagating like this and like this and like this. So like that, so many ways it will, so many angles light is propagating with so many angles, means we will call it as multi-mode propagation. So light is traveling inside only with a only particular angle, means that is a single mode propagation. Single mode propagation. Okay, now first of all we will discuss about the single mode optical fiber, and then after that we will discuss about the multi-mode optical fibers. So then after we will discuss about the step index, and after that we will discuss about the graded index optical fiber. Okay, so these we will discuss remaining in tomorrow class. Okay, so first of all I will take the attendance. If you have any doubts, means you can ask. So today I will discuss some more fastly. Okay, if you have any doubts, means you can ask right now only. Okay, so read once after completion of, so in your textbook it was there, so read once. We will clarify if you have any doubts also. Okay, yeah, so you can leave right now. If you have any doubts you can ask, otherwise you can leave from the session.